Well, so you have to get that. I told you I had a student that did that. Jake Wirt. Sat right there. All right, everybody, shut up! He's like still babbling.
Does that mean hello in Vietnamese?
What? Everybody shut up? Does that mean hello?
It means good morning.
You say it so often, it just means welcome.
Apparently, I think it was. Wasn't last year. I think it was 2 years ago. Somebody had a recording, like cut out the recording of that, and it started making its rounds like through the dorms. Like it became like this cult following thing in the dorms. Like this teacher telling this class to shut up. Yeah, I was pretty proud of that. I feel like verbal abuse is the best kind of abuse. You don't leave a mark. Well, I mean, not like a visible one. You leave a spiritual and emotional scars. Yeah, then you go to chapel with me and sit in the front row. Those get erased so quick in the front row. Where do you think all my hair went? I used to have shoulder length hair before I started going to chapel. The same hair as V here. Just all the way down there. Now. This is it. This is grown out. This is
Can you?
This is short, but this is growing long. Like right here, you have hair.
Yeah, this still grows. This doesn't. It's not so much up here. This is yeah.
You would wear a wig.
Why would I want to wear a wig? Then I gotta wash it.
That'd be fun.
Because you wouldn't have some hair.
Well, yeah, but I don't have that much of it. Yeah, so this is low maintenance, is what I'm saying.
Once a month.
I still do the hair gel, right? You know, make sure it looks like this all the time.
I have to let him tattoo it.
If I ever, I'm too lazy to actually like shave it all off. So I just, I buzz it until it's like stops making cutting noises. But if I literally lost all my hair up here, what I would do is I would get a tattoo of like a big bloodshot eyeball or something. Or maybe an 8-ball. Do Cyclops, but it's a reverse Cyclops. So everywhere you're going, you turn your head, you just freaking out people behind you.
You get a sunglasses that just have one lens that's put on the back of your head.
And then somebody says, "Why are you wearing your glasses like that?" You take it off, and you got the eye. Do they make Cyclops sunglasses?
Probably, yeah.
That's what's messed up, because they probably do.
You know what I'm hearing.
All right, so we're talking about Android, right?
I know.
All right, and everybody got Android Studio downloaded and patched and all that good jazz we talked about at the end of last class? Mm-hmm. Who didn't listen at the end of last class and didn't download it and didn't patch it? Who are willing to admit to it? Who's willing to admit to it? All right, so as a reminder, you go to developer.android.com, click on Android Studio up here, go and download Android Studio. It'll automatically choose whatever platform you're on. So I'm on Windows, so it chooses Windows. If you're on a Mac, it'll say Mac. If you're on Linux, it'll say Linux. Download it, install it, and then open it, and it'll say it needs to have an update thing. Just keep hitting yes, update until it stops asking for updates. Capiche? Capiche. See, isn't that Italian? I think it's Italian. Capiche? I'm fluent in Italian.
They have all those like Cyclops sunglasses from like the movies.
From Percy Jackson?
No.
There was a Cyclops in Percy Jackson.
It was from Marvel.
X-Men.
Yeah.
There was a Cyclops in X-Men?
Yeah, he was like the guy that shot his eyes.
Yeah, but he wasn't a Cyclops.
Yeah, but
That was his nickname.
Yeah.
Oh, yeah.
Visor.
Yeah, I know he had like the visor, but yeah, but he had 2 eyes.
Yeah.
That's not Cyclops.
No.
That was his superhero name was Cyclops. So it was really a poorly chosen, it was a bad name. Cool sounding name, but not an appropriate name.
Yeah, it doesn't really make sense.
Superhero.
Can I download Android Studio on my computer?
Yeah.
Okay.
All right, so let's go back. I want to review here what we were talking about because I was kind of comparing iOS and Android last time, and kind of how the setup is between these guys. Okay, so Android's an operating system. We can say made by Google, but it was actually made by another company that Google acquired. Apple's competitors called iOS. Made by Apple, but based on Mac OS X, which was acquired by Apple when they purchased Steve Jobs, which came with Next Computers, or Next Computers, which came with Steve Jobs. Choose your poison. All right, so those are our two most popular mobile operating systems for our smartphones today. Little, trivia type thing here. Apple's mobile library is something called Cocoa Touch for touch interface. So kind of a fun name thing. All right, so what's an Android app? An Android app is something called a collection of activities, where an activity is a collection of views, where a view is anything that you can see on the screen. Okay, and we have this thing called the view and back end logic. I'm going to come back to that here in a few minutes. All right, so that's what an Android application is. Collection of activities, where an activity is, we can think of it as a single screen on our application, and it's a collection of things that we can see as well as the back end, the logic that makes that go. iOS, we have a collection of UI view controllers, so kind of think of them as like the iOS version of an activity. Pretty close. They have a lot more in common than they have differences. Okay. The UI view controller is a collection of UI views and back-end logic. So on iPhone, anything that says UI in front of it, you can see. Anything that says NS in front of it, you can't see. It's an object built into the library. And NS stands for next step, which is evidence of Next Computers from years and years and years ago, and it's still used today. Let's see. Top level view controller governs all other view controllers that make up the app. So that means applications on iPhone are self-contained. So you have a view controller which calls all the other view controllers for the various screens of the app. You have a starting point, then you jump to other places. Where Android is a whole bunch of separately linked, separate activities that we know as a developer make up the various screens of an application, but an activity asks the operating system to actually launch another activity. And I'll go ahead and give you the academic side of that here. We'll see it, probably not today, but we'll see it in the next couple of classes. But we have something in Android called an intent. I will come back to this. You don't need to necessarily spend too much time thinking about intents right now. But an intent is used for an activity to launch another activity. All right, I'll just leave it at that for right now. It actually can be used for all sorts of other things as well, but our starting use of intent is to have one activity say, I intend to launch another activity. All right, we talked last time that all Android devices have a built-in back button, so you don't need to put back buttons into your apps. Go ahead.
Which one's more efficient, Apple's way of doing it or Android?
Horse and peas. I mean, they have so much in common now. I mean, if you the Android today only loosely resembles Android of the early days, and I think that that's less true on iOS, but still partially true. They've taken a lot from each other and figured out what's the best way of accomplishing different things on smartphones. I mentioned that last class. If you were dealing with the early days of Android, we can joke all we want about the Apple fanboys drinking the Kool-Aid, but anybody in the early days of Android and iOS who said Android was better was out of their mind. It was just an inferior product completely all around. It was not as good of a product. Now, pick your poison. They're both top tier, really good, well-developed. Whoever has come out with the latest software release probably has some bells and whistles that the other guy will incorporate in the next one. just the way it is. So, today you're not stupid for having an Android. That's what I'm saying. But, year 2 of Android, at that point, you're just anti-Apple. Is what it ultimately came down to. It had nothing to do with the quality of your user experience.
How much have both respective companies and our operating systems changed over since they started?
Well, I don't know. I guess I don't know how necessarily to answer that, but I mean, quite a bit. I mean, when you take the operating systems class, I mean, you talk about what are the core components of an operating system. One of them happens to do with memory management and CPU processor management and multitasking, and the whole multitasking model in both of them has altered. So that's a major component of the operating system that's completely modified. Look and feel. I mean, I think if you just got an iPhone this year, let's say, and it's running, what is it, iOS 12 point whatever, that newest.
It's an iPhone 8, but I.
Oh, that's 2 years old.
Yeah, but I just got it.
Oh, all right. So you got the budget pleaser plan because you don't want to pay $1,500 for a phone.
I'm not paying for an iPhone like X or whatever that is. That's just.
Some people like having buttons.
Yeah, that's why I got
honestly,
mine.
it just seems extra.
Everybody who I've talked to who went to an iPhone X or an iPhone XS, who was used to the buttons, said they missed it for 3 or 4 days, and now they're used to doing it the new way. And they like it better. And the best examples of that are my neighbors who are a little bit older and are not techie people. So if they could figure it out, you could too.
Well,
Is what I'm getting at.
That wasn't my issue. It didn't really seem like it was that much of a jump in like processing power.
Well, that's got the same processor in it.
Yeah, exactly.
Well, the same processor as the iPhone X, last year's. The new one has a faster processor, but it has the same processor. But it makes you feel better. My wife, she's still on an iPhone 8. She didn't want to. She doesn't want to give up the home button.
I mean, yeah, I gave up the jack when I upgraded.
Nah, I don't think she cares about that. But
I think I missed that.
yeah, but my wife doesn't like change. Yeah, so it'll be interesting when she starts having battery problems with her phone and she has to go because she's not going to jump Android because she's not going to. You don't want that change, right?
Yeah, I mean that's the reason I didn't know.
But yeah. But in any case, both operating systems are very viable today. They're both really good, and you could pick features of either one of them that trumps some feature of the other one. So pick the device that you like, and whatever the company that you hate, pick the other one. I think you have a lot of people like that who don't like Apple, so they'll just whoever else they'll just pick. Doesn't seem like Samsung has as many haters. You have some people that'll pick other Android devices over Samsung, but it doesn't feel like Samsung has the same like cult anti-Samsung following as Apple does. It's kind of weird.
The comments about the Note 7.
No, that's like a surprise. That's like a present, right?
Yeah.
I mean, when you have a phone that just might explode.
Especially when you're on a plane, that's
Yeah.
surprise.
Oh yeah. Did you see the bag? It was on the news yesterday. There's some baggage, like the guy who loads the bags on and off an airplane. I guess he was drunk and he fell asleep in the cargo hold.
Oh no.
Guy went on like a 5-hour flight. Luckily, it was pressurized.
Yeah.
It's pressurized and heated. Otherwise, this guy would have been in an unpressurized cabin that was sitting at like minus 40 degrees or something.
Terrible.
They might not have found a real great. Apparently, he was still sleeping when it landed.
Surprised there wasn't a big accident.
Well, I'd probably start pressurizing the cabins anyways.
I think for the forward cabin is pressurized because that's where they carry like pets and stuff.
Okay.
Yeah, because your pets aren't going to do so great in below freezing, unpressurized. Yeah, it wouldn't work out great. So he lucked out. He fell asleep in the right cabin. Okay, so let's start looking at some examples. Let's actually look at Android Studio. Start with something from scratch. So I'm going to open up this. I'm going to close this project. This is a project from a different class. Hopefully it doesn't just automatically reopen that one. Big money, big money.
Fatal error has occurred.
It did just reopen it. That's fine. We'll start a new one differently. All right, so I'm just going to close this project. I'll also terminate that. Don't worry about anything I'm doing right now. All right, so when you first open up our Android Studio, you'll kind of have a screen that looks like this, right? So you can click and say start a new Android Studio project. So that's what we're going to do. And we can call it whatever we want. So let's call this guy CSC250 Android Starter, whatever. And you can store this guy wherever you want. Doesn't really matter at this point in time. So someplace that you can find it later. You don't need to include C++ support. You don't need to include Kotlin support. This is another programming language that you can use instead of Java. We're not doing that. We're going to do Java stuff. All right. Just leave the domain thing set where it's at. It's probably something.example.com right now. Doesn't matter. Just leave it. Go ahead and hit next. All right. So now this is kind of where it gets interesting. Last time we talked about that when we think about Android, we typically think about phones, but Android actually exists on several different platforms. So we have Android, their Wear OS, which is like for the smartwatches, that kind of stuff. There's also Android for TVs. There's Android for cars. Any of you use Android Auto for your car or Apple CarPlay? Either one of those?
My brother does.
Yeah, so like in my car, I have an Android smartphone, so I plug this in and Android Auto automatically launches in my car, and then I can use Google Maps and several different apps. I listen to my Audible audiobooks through there and all that stuff. So you have a way of having your phone drive a Android application that is presented on a larger screen inside of a car, and you have to imagine your interface in terms of that car screen, right? So even though these are all Android, and then Android Things is something that's part of Internet of Things. Let me go ahead and add that to the notes because that's an interesting thing. How many of you have seen that little acronym before? All right, so this guy stands for
Internet of Things.
Internet of Things. And do you know what that really means? What is the Internet of Things? Go ahead.
Anything that's connected to the internet, so like your toaster.
Yeah, anything that's hooked into the internet, and every single day we come up with new things that we think need to be connected to the internet. Like you mentioned, toasters. Now you have toasters that you can connect it to the internet. You can connect it to like your cloud, like Dropbox or something like that. You can put pictures in that Dropbox, and then it'll show up on the interface on there, and you can print on your toast a picture. Did I mention it here one other time, like Yoda toast? Yeah, you can have Yoda make Yoda toast, which I think everybody needs. Right? It is unnecessary, but we still need it.
Really?
Yeah.
Those would be contradictory terms, unnecessary and needed, but I still think it's true for some reason. Yeah.
I agree.
Now we have smart fridges that'll tell you like when you're out of milk or something like that, or you can at least talk to when you look in there and you say, oh, I'm out of milk. You could tell your fridge to add milk to your grocery list, which will talk to your other Android devices or work through Alexa or, whatever, that kind of stuff. So we have all sorts of smart devices around us today. I can't even manually turn lights on and off in my house anymore. You have to, the gatekeeper is Alexa. Okay, and now it's even worse because now my wife in our master bedroom, she doesn't turn the lights all the way off. They're like at like 5%. So it's like almost like a mini nightlight type thing. We have two lights in there. Well, so now in the morning, I can't just say, Alexa, turn the bedroom lights on, because they're already on. Okay? I have to say, Alexa, turn the bedroom lights to 100%. All right. And then what I do to mess with her, because usually I'm already out of the house while she's still getting ready, is I have them turn like some weird color, because we have the color light, so I can say make it like blood red or something like that. Okay. Or you can do like Alexa will play music, and then you can have the lights go with the music.
Halloween, oh.
And then I set Mr. Gonzalez up in some part of the room, like doing something like, I don't know, creepy usually. So basically, there's more evidence that I'm a giant 5-year-old. It's just kind of. So in any case, we have Internet of Things, and a lot of our Internet of Things devices are running various. Some of them are proprietary operating systems, but Android's a pretty common operating system to be running on a lot of these devices. Do you know why? Why is Android such a common operating system for other devices, whether it's non-Google? Well, Google doesn't even make a smartwatch, but so why does company X have Android on their smartwatches or have it on their TV products or something like that?
Isn't like the base Android like free source?
Yeah, Android's open source. Our printer down there has an Android operating system running on the tablet that's attached to the thing, right? Android's open source, iOS isn't. That doesn't necessarily mean that they wouldn't pick Android anyways, but if you have a free operating system available to you rather than having to license one, might as well go that route. All right, so Internet of Things is another thing. So when you come in here and you're creating a new Android project, notice that we can choose what we're building this guy for. Mm-hmm. So the default is phone and tablet. So we're going to leave that guide checked because that's what we're going to be looking at it. But the reality is the way we would write Android apps would be equivalent across the board, whether we pick any of these different devices in terms of kind of our fundamentals, the thing, how buttons work, stuff like that. The things that would change between devices is going to be screen size, screen layout. So obviously a watch screen is going to be a lot smaller than a TV screen. Okay. And then there might be some widgets that are specific to some of those things. Like if you've used a smartwatch before, there's certainly some stuff inside of, when you're using a smartwatch that isn't, an interface widget that isn't really available on a phone or isn't available on a TV because it was specifically designed to be used on a watch, right? It would kind of be inconvenient to use on a TV. All right. So we'll pick phone and tablet. Now this next thing here, this drop down that says API. So does anybody know what API stands for? We've seen those 3 letters next to each other before, right? All right. So this is abstract programming interface. And that's actually probably one of a couple of different things that somebody might say it stands for, but it's roughly, this is what it means. So an abstract programming interface says this is a collection of, I'm going to call it libraries, which is a fancy way of saying let's maybe functions. Okay, collections of function. So a collection of functions that allow us to accomplish something. So some examples, if you're writing a mobile application and you want to have Google Maps available in your application, you might import the Google Maps API. And that guy's going to have a whole bunch of functions for, navigating, for, picking a destination, getting the distance between places, time left, current speed, stuff like that. All right. So stuff that's Google Map-y. Makes sense? All right. Similarly, we're going to be doing for the hackathon, we're going to have a boot camp on the Monday before the hackathon. We're going to be looking at machine learning. So it's an artificial intelligence type of thing. And we're going to be using an API for machine learning. All right. So, that boot camp will take you through doing some machine learning stuff. And we'll probably also look at some of it in here. And if you haven't already done so, make sure you email Professor Josh Locklear to sign up for the hackathon so he gets your name on the list as soon as possible as you start putting together teams. Who, what? A couple hours probably.
What time does it start?
I think it's at 6. Check, it's on Slack. Yeah. And I'll record it as well. All right, so there's an example of an API, like doing something like Google Maps API or a machine learning API or maybe a PayPal API if you want to incorporate payments into an application. It doesn't just have to be a mobile app. You can incorporate payments into a desktop application for, maybe it's a Windows.NET application or something like that. So APIs aren't specific to mobile applications. They're a way for us to get functionality that has been developed by somebody else into our applications so that we don't have to reinvent the wheel. If you're creating an app that's going to sell something, you don't want to have to create your own payment system. You can leverage PayPal and bring it into your app and just use PayPal. Make sense? All right, so that's what APIs are used for. So when we go back here, notice we have this drop down for API level. What this is talking about is it's talking about the API for the actual operating system. Okay, so when we have an operating system that runs on a device, any software that's running on that device has to be implemented in terms of the functions that that API provides. Okay, now as newer operating systems come out, they usually announce new bells and whistles, right? Okay, so if you have the latest, greatest, Android phone, the latest, greatest iPhone that's running the latest software, you can do things that wouldn't have been available in the previous software, right? It's a true statement. Well, so if somebody writes an application that takes advantage of some of those new bells and whistles, that application will not run on older versions of the software because it doesn't have those bells and whistles. Make sense? That's a trade-off. As a developer, if we are writing, so let's kind of get this in here. So we choose an API level that includes all of the functionality that is required for our app. So if we've imagined our app having interface widgets and using special bells and whistles and things like that that were already available in the Android from 4 years ago, we might as well pick that because that's going to make our app available to the largest population of people. Does that make sense? Whereas if we decide we're going to create our app for the the brand new Android 1 API, even if we choose not to use specialty widgets, we're still compiling it for that version, and it will not run on older versions of the Android operating system. Make sense? So typically when you write an app, you want to pick an API level that includes all the features that you intend to include on your app and not necessarily anything more. So your app is available for the most number of people. Having said that, you might also allow the number of people you want to have the capability of running your app drive the widget you choose to use in your app. So maybe there's some new feature in the latest, greatest Android operating system. You say, hey, that would be really cool to use. And then you say, well, but if I choose to use that in my app, not that many people are going to be able to use my app. So I'm going to choose not to use that brand new bell and whistle because I want to play to a larger audience. That makes sense? So when we go back here to this, notice the default here is API 15, which is Android 4, which is ice cream sandwich. And notice underneath here it says, by targeting API 15, your app will run on approximately 100% of current Android devices that are out there. All right, but if I hit this drop down here, and let's go all the way to the newest, so Android 9, so this is Pi. This will run on less than 1% of devices that are out there. If I go to Oreo, about 1.1% of devices. Okay, that's last year's operating system.
Yeah.
You go to Nougat, yeah, they name them all after like sweets and stuff. So you go to Nougat, this is 2 years ago, 14%. Marshmallow, 62%. Lollipop, 80%. Kit Kat, 95%. Jelly Bean, 96%. Go back to ice cream sandwich. Now we're at 100%. So we're kind of seeing this here that the newest version is 4, or newest version is 9. And the first version that hits 100% of devices is 4. That kind of corroborates something we mentioned last time. We talked about how, when you look at some numbers, they'll say, oh, well, Android has way more devices in circulation than iOS does. But the reality is, in terms of viable audience for applications, typically it's either about the same or actually iOS has more viable phones for applications. Because what we're looking at here is we're looking at the Android operating system from 5 years ago is what we can assume everybody has at least that availability on their devices. After that, we're cutting out 10% of the population or 40% of the population or a lot more percent of the population. Make sense? Where typically if we look at what percent of iPhone users are running the latest, greatest iOS 12, it's probably something like 80% are running the very newest. And then 100% probably encapsulates the operating system from the last year and a half or something like that. All right, so much less fragmentation on the Apple side of things. Okay, so when you're writing an application for an Apple device, you're more able to target the latest, greatest features for your application because you can rely on more people having it. You could take it even to another level, something I mentioned last time. If you're writing apps for mobile devices and you want to make money off of it, you're better off writing for iOS than Android if you're only going to target one of them. You're best off writing it for both, and they make money from both sides, right? Their pricing model's the same. So they take 30%, you get 70%. So when you put your app up and you say, I'm going to sell it for $1, Apple will, every time your app sells, Apple will take 30 cents, you get 70 cents, and Apple handles all the credit card transactions and all that stuff. So you don't have to do any of that stuff. Plus, Apple gave you access to their millions and millions and millions of customers. Similar on Android side. So, hey, you don't want to give them the 30%? No problem. You can market your app yourself. Okay, by the way, your iOS app can't be marketed itself because there's no way to install it without them jailbreaking their phone. So you're working with a much smaller audience. On the Android side, it's easier to distribute your application to the public without using the Android Play Store. But don't you think the Android Play Store is going to get your app in front of a much, much, much larger audience than your website?
Yeah.
Probably. All right, so it's probably worth the 30%. All right, and just to kind of maybe get you a little bit excited about this stuff, we have had plenty of students in the past take this skill set, go and learn the iOS skill set as well, and start writing apps. And we've had students make $20,000 or $30,000 while they were in school selling apps on the App Store. Okay, so probably going to beat your $8 an hour job somewhere if you decided to get into that. Make some sense? All right. So punchline for us here is we'll pick an API level of 15 because we're not going to be doing anything super fancy. But we're going to be learning the fundamentals that we can apply to any of the fancy stuff. They all work the same. So when a new widget comes out, our knowledge from previous versions of Android will directly allow us to start using that new widget, and we don't have to learn a completely new language or something. All right, so we'll leave the default as API 15. Make sure you choose phone and tablet. Now, we have this little checkbox here that says include Android Instant App Support. All right, so I'm going to go ahead and click that. And I might regret this later, but we're going to do it anyways. So one thing that we'll see here is we're going to have an emulator that we're going to launch that kind of gives us the Android operating system running on a fake phone and software, so you don't have to have an Android phone and hook it into your computer to run it, even though you can. If you have an Android phone, you'll be able to run any of your apps on your phone, no problem. If you have an iPhone, you won't be able to run Android apps. All right, but you don't have to have any smartphone. You'll do it right on your computer. For some of you, The emulator will take some time to launch. All right. And sometimes when you want to test your app in between runs and you hit play, if you don't have the instant app support, it will have to relaunch the entire app. And if your emulator is slow, it'll take some time to relaunch it. The instant app support will make it launch instantaneously because it actually only relaunches the parts of the app that you've changed. But I've also noticed it is a little bit sketch on some computers. So if you have issues with this, just uncheck that checkbox and create a new project. But yeah, it is what it is. So I'm going to hit next. This says requires Android Instant Apps SDK component not installed. Do you want to install it now? I'm going to say yes. So it's going to go and download this dude. And it looks like it's downloading pretty quickly. So do this, offline, create your your first project like we're doing here. If this ends up taking too long, I'll just back off of it. Okay, there we go. So I have that component now installed. I'm going to hit finish. Let's see. Is Instant App not what I think it is? I don't think it's what I think it is. I hit previous. I'm going to uncheck that. What I explained does exist. It must not be called Instant App Support. All right, so phone and tablet, API 15, don't check this. I'm going to hit next. Now, notice there's some starting points for activities. So we can have a basic activity, which kind of gives you a little button thing on here. You can have a bottom navigation thing. You can have a page turn thing. You can have a map thing, fragments, all sorts of kind of starting points. For us, and pretty much for always, I always start with an empty activity. I like to build my interfaces from scratch. That isn't to say some of these other ones might not be incredibly helpful, but typically there's going to be a little bit of a learning curve figuring out how did Android decide to make this guy work. Not the end of the world, but since we're learning about fundamentals here, I'd rather not have any extra stuff done for us so we can just look at it as straight starter code. Okay, so I'm going to choose an empty activity, not to be confused with a blank activity. We're going to do an empty activity. I'll hit next here. And typically your activities, your starter activity, it names it main activity. And then you have a checkbox that says generate layout file. And then you say, usually you'll name it activity main. So I'm going to stop here for a second. I think we've discussed it in here, but if we haven't, we're going to definitely discuss it now. You've definitely maybe heard it in one of my other classes. Have we talked about MVC?
Yes.
Okay. So what does MVC stand for again?
Controller.
Model View Controller. And what does it basically say? What's the concept behind MVC?
We have different different places for all our information sectioned off, whether it's
Interface and logic.
Yeah, it's a good idea to separate the interface from our logic from our data. So you were saying the right thing. Stuff is separated. You were just saying it in a really horrible way.
I was.
All right. So the idea here is that as we get into complex applications, and an Android application by default already starts off as complex because all sorts of stuff is getting done for us that we had nothing to do with. But the second we create this project, it's going to, set up all sorts of manifest files and all the magic that's going to be required from when we hit the play button for it to actually launch an app. Okay, so it's doing a lot of stuff for us. So even though we haven't written any lines of code yet when this thing first starts, I'm going to guess and say there's probably 1,000 lines of code that are involved in a blank project. Okay, that we don't have to deal with. But punchline is it's kind of a complex application. So the idea is as our applications get more and more complex, we want to start taking advantage of design patterns like MVC. Now, MVC is an idea. We are reliant on that being implemented into whatever technology we're using. So in this case, we are using Android Studio. So what we're interested in is, how did Android Studio implement MVC? How did Android Studio allow us to design our interface in one place, write our back-end logic in another place, and then allow us to have those guys talk to each other? All right, that's going to be one of the skills we're going to learn. And right at the top level here, we see the starting point of this, where you say, we're going to create an empty activity. The activity itself, this is the Java file, that's our controller. Then we have the checkbox that says, do you want to generate a layout file? Yes. We're going to name it activity_main. Doesn't matter what you name it. That's the default name they gave it. That's our interface. Backend logic, the controller, view, the interface. All right. So we'll go ahead and define that for Android. So for Android, we have the view is our layout file. And this guy is an XML document. Talk about that here in a second. And then we have the controller. This is our, I'm going to say this is our activity file, which is a Java document. That's our code. So we'll say /code. All right. Now, model for us right now, I'm just going to put some question marks. All right. Because this is the third piece of the puzzle. This is if we want to incorporate a database and stuff like that into our code, which we will do eventually. But right now, we don't care about that because it's not in our purview. Okay. But there will be a way for us to also have a third piece of this puzzle where our data that maybe holds stuff between multiple runs of our application. Right. So if you run your application 10 times, you don't necessarily want to have to start from scratch each time. You want it to kind of remember where you left off the previous time, or, that kind of stuff. So we need to have some way of also representing data. And that's also stored separately, done separately. All right. So that's the concept of MVC as it applies to Android. The view is handled by layout files. The controller is handled by our Java file. And don't worry about model for right now. Now, I think we have talked about XML before? Probably. All right, so what is XML? You know what it stands for? Well, first of all, I'll ask you this, because when we would have talked about this would have probably been in 200 when we were introducing the history of programming languages, and I probably said something along the lines of a lot of times on like a resume or something, people will list, oh, here's the programming languages I'm familiar with, and one of them they'll list is HTML, and then I'll ask the question, is HTML a programming language? Just like right now, I'm going to ask you the question, is HTML a programming language? What is HTML? The web stuff, the web language. Is it a programming language? What does it take for a language to be a programming language? Whoa, go ahead.
Convert from like a high level to a low level?
That's a compiler. That's what a compiler does. 100% of all programming languages give us what?
Variables, loops, or iteration.
If statements.
Yeah, ask questions, right? So how do human beings solve problems? We use our memory, we ask questions, repetition. 100% of programming languages will have facilities for those three things. Memory through variables, questions through conditionals, usually if statements, because most of our modern languages come from C, and then repetition through loops and functions. Okay? 100% of programming languages will have facilities for those things. That's the reason why the language does not matter. Okay, I cannot emphasize that enough. In fact, some of our seniors who are starting to go through some job interviews and stuff like that are seeing that in their job interview, there's like a coding question, and they ask the questions. They give you sample code in different languages on the same test. Not because they care whether you know that language. If I show you some code that was written in, how many of you have used Swift before? Good, perfect example. If I show you some code written in Swift, do you think you probably will be able to read it? Yeah, for the most code. For most code. For the most part, you would be able to read it, right? There might be a couple of weird things in there, something like that. It says, oh, I wonder what that does, but I pretty much get what this is doing. What are you going to see? You're going to see variable definitions. You're going to see if statements. You're going to see some loops, some things that kind of look like functions. Okay, you're going to see all sorts of stuff that you're already familiar with. Sure, there's a small little syntax difference and the little idiosyncrasies here and there, but in general, it's not going to look completely foreign to you from a programming language perspective, right? Okay. How many of you, let's go, can read or speak Russian?
I recognize some of the characters around.
You see, Russian, that's the one I always find to be very fascinating because it uses the Cyrillic alphabet, right? Have you ever seen words written in Russian? Okay, somebody might as well be drawing pictures, right? I mean, you don't even know how to pronounce that, right? Okay, so the thing is that now if you're looking at different languages, depending on kind of its root language, you may or may not, I mean, you might not be familiar with the alphabet of that language, right? There's actually a really funny YouTube video you should watch at some point if you're not easily offended, called The Machine. It's a comedian. Not classroom appropriate, but the Russian thing reminds me of it. You know, he got a minor in Russian. His teacher convinces him to take these classes, and he wasn't even familiar with the alphabet. He went on this Russian trip, and he gets involved with the Russian mobsters and stuff like that. So it's pretty funny, but not something you'd want to listen to in public. You know, like with a mixed audience. All right. So in any case, punchline is if you were familiar with a language that had a similar root language. Well, if you were familiar with one language, what was that? That was loud. You were familiar with one language, and you had another language, another natural language that came from the same root language, you might have a fighting chance, right? Just like in our programming languages, if they came from C, which almost all of our modern languages did, we're going to have a pretty good chance of being able to read large chunks of it and have a pretty good idea what's going on. And consider that, generally speaking, so most of us in here still find programming pretty difficult, right? Okay. How many of you in here find English difficult?
In what sense?
Any sense. Did you have to think very hard to ask that question?
No.
Just popped into your head, right? So English is pretty easy for you, isn't it?
Yeah.
Okay. But programming, pretty hard? Yeah, it's pretty. Yeah, it's a difficult thing, right? Which do you think is more complex, programming or English?
English.
By a lot. They're not even in the same universe in terms of which is more complex. What a programming language can accomplish is such a small subset of what a natural language can accomplish, right? Plus, natural languages have nuance. You know, the way you say something, facial expressions, all sorts of things add to what what you're saying. So imagine how easy you find something that is amazingly complex, like English. And then imagine how much you struggle with something that's amazingly simple, relatively speaking, like in this case, Java.
Well, talk to me again after 18 years of programming.
Well, but still, I mean, this is still a true statement, though. I've been programming since I was 9, so a lot more than 18 years. Which do you think comes more naturally to me, English or programming?
English.
Still English. I get by with programming. I'm pretty good. I mean, I'd like to say it's closer than it should be because I'm weird. But in general, English, which is significantly more complex, right? And I really haven't been using English that much longer than programming in the big scheme of things, right? I mean, at what point do you really start saying words and putting them together in sensical ways? Kind of like when you're 4 or something, 3? So I've been doing programming, I've been doing English 6 years longer. than programming. So in terms of time they're in the similar ballpark, right? Yet I don't have to think about English. I don't have to think about a lot of programming. A lot of it's just these these kind of fundamentals that I kind of focus on. This whole idea of memory, asking questions, repetition. Those fundamentals, once you get used to those, you can just write a loop in your sleep and stuff like that. But if you're solving any sort of complex problem, you got to think a little bit, right? Yet if somebody's asking you for directions to the closest McDonald's, or hey, let's look at more local here. Hey, where's the closest bathroom? You don't have to think that hard. You just kind of say, well, where am I? It's right out the door down the hall to the left. Right? It didn't take a whole lot of horsepower for you to problem solve that, right? Because we're really good at solving problems. Just computers they kind of enamor us. It's difficult. Okay, so getting back to these old languages, I would have probably mentioned something along the lines of something called a data representation language. All right, so when somebody writes down, so never do this, by the way, because this will hurt you in when you turn your resume into something. Okay, so as a computer scientist, when you're applying for an internship or applying for a job, and you're going to put on there, here's the programming languages I'm familiar with. Never, ever, 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 ever put HTML under the list of programming languages, because it's not a programming language. It's a language. It's a data representation language. It's really good. Doesn't mean it's less of something. It's just not a programming language, because programming languages allow us to represent memory, asking questions, repetition. HTML does not do that. How do we know? Because HTML is the thing that we use for making web pages in our web browsers, and the fact that JavaScript even exists as a language tells us that it's the complement to our non-programming language HTML to make things happen programmatically, that have logic actually occur. JavaScript allows you to create variables. JavaScript allows you to ask questions, allows you to write functions and have loops. Okay, and those things are what run inside your web browser to allow you to do like form validation. Did the person even enter their username and password before I let the submit button send it somewhere? Does that make sense? All right, so a language like HTML is not a programming language. It's a data representation language. So we can say HTML is an example of one of these. Anybody know what this stands for?
Oh,
Hyper?
text, something like.
You got none of them. Language. I should have just written. Well, I wrote the hyper in the text, didn't I?
I said hyper first.
Oh, did you? Okay, I'll give you a quarter. I'll give you 33%. All right, so hypertext markup language. So this guy represents, it's a data representation language that is interpreted by a web browser. So this guy is interpreted by a web browser to show pretty pictures and text. That's what HTML is. Okay? That's been around for a long time. That's the thing we use to represent our web pages. And if you want to see this in action, if I come in here, I'll just take this Android Studio page as an example. I'll right-click on this. I'm going to say View Page Source. And there's a whole bunch of HTML.
There's no loops or anything in there.
No loops.
It's kind of the same thing as XML and JSON. Like as far as
yeah, so now we're talking about a chicken or the egg problem. So let me go back here and talk about that. So some other data representation languages. We have XML and we have JSON. These are also data representation languages. Now, XML stands for Extensible Markup Language. Okay, and this guy actually came after HTML. So HTML is a tag-based language where in HTML you have a tag and a closing tag with stuff in between. Notice that closing tags have that little front slash there. Okay, but we have these tags that have the angle brackets and that kind of stuff. That's kind of the syntax for HTML. So HTML HTML specifies a list of magic tricks, if you will, okay, a list of available tags for like making text bold or making something a table, making rows in a table, making columns in a table, stuff like that. Well, the XML idea was like, look, HTML is a pretty effective way of representing stuff that's specifically part of web page stuff. What if I wanted to represent other kinds of data using this tag-based language? Okay, and this really has to do with APIs. Okay, so for example, if I'm dealing with HTML, we might have a title and a slash title as an example of HTML. I'm going to put like my page in the middle of that. All right, so in HTML, we have a title tag that allows a page to have a title. So here, in this guy here, the very top, so this says download Android Studio up here. So if I do view page source, again, somewhere up here at the very, very, very top, so there's my title, download Android Studio and SDK tools, blah, blah, blah. That's this guy that shows up here. Make sense? So this is how we represented that piece. And what did our web browser, Chrome in this case, do? It turned it into a whole bunch of pretty pictures and text, and it put our little title up there in the tab. Make sense? So somebody finally said, you know what? If I have one program that needs to talk to another program, and I want to send data between these two guys, that data needs to be formatted in some sort of way that I can easily pull out the important information. All right, I can pull out the important information. Because maybe prior to this, people just did it as like comma delimited stuff or something like that. But now maybe with XML, I can do something like person, and maybe this person has a first name, Mike, and a last name, Littman, something like that. All right, so these aren't things that are really necessary for HTML for making web page stuff show up, but this might be data that two programs might want to share with each other, and then using a tag-based language to represent that data could be helpful. Make sense? So that's where XML came from. So XML says, hey, we're going to take some influence from HTML and say, let's go ahead and let's build our own tags for other things to represent data that two programs could parse. You know, one program can send to another program this HTML data. That program, the receiving program, could then parse it and get the Mike and the Littman out for the first name and the last name. Make sense? Now, in the middle here, though, we do have this thing called XHTML. How many of you have ever seen that before? Those words put together like that, XHTML. If I come, let's see, if I go to settings here, I won't search for real long, but I probably could find it fairly quickly. Somewhere in here, there's going to be like an option to like allow XHTML or enable XHTML. What XHTML is it's the HTML language represented in XML. And so you might say, well, what's the difference? So that kind of becomes a chicken or the egg thing, right? HTML is the thing that influenced the existence of XML. Then we use XML to define HTML. Okay, but we call that XHTML. And this has to do with going back to the early days of web development, where we had, if you were a web developer, and this is still somewhat true today, when you create a page, you have to test it on different browsers. because a page might not necessarily look identical on Chrome as it does on Microsoft Edge, as it does on Safari, so on and so forth. And this is really an old problem because in the early days of the web, these various web browsers, which now have to be backwards compatible with old pages, so all these pages will still show up, it allowed relatively loose HTML code to work. You didn't always have to have a closing tag. It kind of let you get away without having a closing tag. So it allowed you to write HTML that really wasn't proper HTML. It was close to proper HTML. Where we think about like Java, when we write something, if we're off by even just a tiny, tiny bit, we get all sorts of errors, right? That wasn't the case with how our web browsers dealt with HTML. So in a web browser now, you can actually enable XHTML. And what that does is it tells the web browser to treat all these pages, any page you load, as being perfect HTML. So what you'll see then is you'll be able to see pretty quickly which pages are written, let's say, competently using correct HTML, and which pages took some shortcuts. I'm trying to think of the name of the program. There was a Microsoft had a program for writing web pages in the very early days. That's how long it is. I'm kind of forgetting it now. But in any case, a front page, Microsoft front page. So Microsoft had an application called Front Page that allowed you to kind of basically like write your web page as if it was like a word processor document, and then it would save it as HTML. And it wrote terrible HTML, like not even close to accurate HTML. And it looked great in Internet Explorer, right? So Internet Explorer allowed for like a really, really bastardized version of HTML. Okay, but point here is that if you enable XHTML, it will many older pages will likely break. All right, so typically it's left off, but that's where if you ever see that, that's what it is. This is HTML defined using XML. So that means you have to follow the rules. Now, the next level down here is something called JSON. Anybody know what JSON stands for?
JSON? JavaScript.
This word right here, JSON.
JavaScript object notation.
Yep.
Oh my God, I got it.
JavaScript object notation. Okay, so this actually comes from how we define objects in a language like JavaScript. So in this, if we wanted to represent that same data up there, I'll just put it all on one line just for the sake of whatever. So I'm going to say fname Mike.
Wow.
That same data there now is represented as a person string in JSON. So notice how much more concise this is than all of this. All right, so we're going to say that JSON is kind of our upgraded version of XML. In any case, all of these things are what are called data representation languages. It allows us to represent data inside of some sort of structure. So XML gives us an opening and closing tag structure, whereas JSON gives us a comma delimited name value pair structure, kind of like a dictionary from Python, but it actually goes even further because it also supports arrays. You can have array collections. All right, but in any case, these are all data representation languages. So now if we bounce back here to Android Studio, notice it's saying I'm going to create a layout file for you, activity main. So I'm going to go ahead. So this is that implementation of MVC, right? It's going to give me a logic file called main activity. And it's going to give me an interface file called activity main. I'll go ahead and hit next. I'm going to go, it's downloading some stuff. What is it downloading? Some build tools or something?
Looks like it.
That's fine. I'm just going to pretend like it worked. So I'm going to hit finish. That way I can at least show you the next stuff. All right. So that's going to open up your interface thing here. And notice right off the bat, it kind of sort of looks similar to Eclipse, right? So if I go in here, notice underneath my app. So here's my app up here. Don't worry about Gradle or Idea. Here's app. Inside of here, I have a folder called source. Inside of there, I have a folder called main. And inside of there, I have a folder called Java. And ultimately, inside of there, I have my main activity. That's this guy. Okay, so that's my Java file that was created for me. Also inside of main, I have a folder called res. So notice we have all this crap in here. Okay, the one that we care about right now is going to be our layout folder. And inside there, we have this activity main.xml. All right, and that guy shows up right here. It's because this guy hasn't synced. But if I go to the text version of this, let me hide this real quick. Notice this is that opening closing tag type of syntax. So this is an XML based syntax here. I'll go ahead and let this guy try to download real quick and see if he cooks so I can get this launched. Go ahead.
Why did it automatically initialize with the git ignore?
Because we can check this into GitHub, and I'll show you that when we do it. And if you remember, like we did this with Unity,
right,
to check it in, and we had to choose Unity as the things, like what things in Unity should we ignore so it doesn't load a 4 GB project up to the cloud.
Right.
This ignores the things that Android Studio will always recreate for you that you don't need to store in GitHub.
I mean, like, does it just assume that you're going to be pushing it to GitHub then?
It prepares itself for pushing it to GitHub.
Huh.
All right, so let me hit finish here. So it uses this thing called Gradle. Okay, and what Gradle is what something called a build tool. And the older version of this was something called Ant, A-N-T. That was something that was from Java in the very, very early days. So I mentioned a little bit ago that your this Android project we just created, even though we've written zero code, really does quite a bit of stuff, right? There's a lot of complexity to it. We see all these folders that were created over here that we didn't do anything for, right? We didn't have anything to do with those. So what Gradle is doing is it's mashing all of our stuff together to give us an actual application that can run. All right. So my Gradle is syncing right now. It takes a little longer the first time it syncs, but hopefully when it's done, some of these red things will disappear. So still downloading some stuff here. And then hopefully in our last couple of minutes, I'll be able to show you a running app. And it's downloading a bunch of stuff, isn't it?
Yeah, that's a lot more than I got.
Yeah, that's what I was trying to say. Like, it's not like you said it.
But hopefully this is at least some evidence about the number of things that are happening behind the scenes. And this only happened one time when you first get your first project working. But until Gradle finishes building your project, you won't be able to actually launch it. Notice the little play button here is emptied. We can't see that yet. When we are updating, I'll just kind of take you on a little tour here while it's kind of doing its thing. when we do have our XML file open, you will have a visual representation of your screen where you can drag buttons in and stuff like that. Usually you can accomplish, let's call it 90% of the stuff you might want to accomplish by just dragging buttons over into that screen. But every now and then, the drag and drop thing kind of won't let you quite drop something the exact place you want to put it. In that case, you'd want to hit the text tab, and you can go in here and actually manipulate the XML directly to get it where you want it to ultimately be. That makes some sense? Okay, so I'll just let this guy keep cooking. What we'll do, so you have Bible homework over the weekend, so make sure you get that done. Make your other assignment to make sure you email Professor Josh Locklear to sign up for the hackathon if you haven't already done so. So get it on your calendar and email him so he can start building that list. And then I will see everybody on Tuesday. This guy should be done updating, and I'll show you how to create your emulator. I'll show you some of our fundamental basic things, and then we'll have an assignment dealing with Android due on Thursday. Sound good? Questions, comments, concerns, bribes? I will see everybody on Tuesday.